Okay, let's study logs. Okay, so let's consider the function f of x equals 10 to the x. And let's see what values this function takes as we input different values of x. So when x is equal to 1, f of x, which would be 10 to the x, so since we're inputting x equal to 1, it would be 10 to the power of 1. So f of x would be 10. Now, when x is equal to 2, we look at what 10 to the power of 2 would be. Well, that would be 100. X is equal to 3, 10 to the 3 is 1,000. X is equal to 4, 10 to the 4 is 10,000. So we have represented this f of x equals 10 to the x in tabular form here for 4 different values of x. Now, the big question, what is f inverse of x? Now remember the definition of an inverse function. So f to the minus 1 of x, f inverse of x, is such that if I input the value of the original f of x, I'm going to get as output the value of x. So let's make it less confusing by looking at an example in tabular form. So if we consider f of x is equal to 10 to the x, f inverse of x has to be such that if I input this value 10, which is what f of x gives you when x is equal to 1. So if I input 10 into f inverse of x, the output should be equal to a 1, which is what I've got represented here in the table that is showing what values f inverse of x produces for different values of x. So continuing with keeping the definition of the inverse function in mind, we see that if I input 100 into f inverse of x, I should get as the output a value of 2. If I input 1,000, I should get 3. If I input 10,000, I should get 4. Okay, great. Now, the question is, what is an equation that I can write for f inverse of x? I see it in the tabular form. I see the characteristics of f inverse of x. But in equation form, how do I represent f inverse of x? So we see that up until now in our mathematical vocabulary, we don't have the components that we need to write what f inverse of x should be in equation form. So let's create some new vocabulary here, which is a very typical thing as mathematicians you will need to do. So what we're going to do is we're going to define logs. So log of x to the base 10 equals a is such that 10 to the power of a should give you x. So what is log of x? Well, log of x, first of all, you can't just say what is log of x, you have to specify what the base is. So log of x to a particular base is the exponent to which the base has to be raised in order to get x. And that's just how we've defined logs here. So what we notice immediately is that f inverse of x for f of x equals 10 to the x can be written as log of x to the base 10. So to clarify this even further, let's represent our f of x and our f inverse of x as these logic machines. So f of x is 10 to the x, f inverse of x is log of x to the base 10. Now, remembering the definition of inverse functions, what we should notice is if we input 3 into f of x, well, what do we get? We get 10 to the x, 10 to the 3, which is 1,000. So what we should notice is if we input 1,000 into f inverse of x, we should get a 3, the original input into the f of x. So let's see if that works. So log of 1,000 to base 10 is the exponent by which we need to raise 10 in order to get 1,000. So what is that exponent? The power of 10, which yields 1,000. Well, 10 to the 3 is 1,000. So log of 1,000 to base 10 is equal to a 3. And we see that the relationship between f of x equal to 10 to the x and f inverse of x equal to log of x to base 10, the relationship between the two functions holds as per the definition of inverse functions. We input 3 into the original function, we get 1,000. We input 1,000 into the inverse function, and we get a 3. Okay, let's stop here, and we'll continue with the definition in the next lesson.